us today. Thank you, Desiree. This is our training on solar PV permitting and inspections. My name is Christine, and I am a regional environmental planner with the Naugatuck+Valley Council of Governments. Just wanted to go over a couple of quick housekeeping things. First, please feel free to use the chat to say hello and share where you're from, and maybe pop in why you're interested in this training. We'll ask you to keep your mics muted, please. Questions can be put in the chat during the presentation, or if you prefer to ask verbally, we'll have some time for that at the end. As I hope you all saw with a little pop-up on your screen, this meeting is being recorded. We will post the recording and our slideshows to our online Solar Hub. I will drop that link in the chat right now so that everybody has access to it. There you go. And furthermore, if you did miss our last meeting, which we held last week, we did a training on solar PV planning, zoning, and development. The recording is posted on our YouTube channel, and I've also pasted that link in the chat. So with that, I'd like to share a little bit about our organization, NVCOG. The Naugatuck-Valley Council of Governments is a regional planning organization for 19 municipalities in West Central Connecticut, and the federally authorized metropolitan planning organization for 15 of those communities. We coordinate planning and provide technical and support services to the region's decision makers. And VCOG is working with SolSmart to achieve a nationally recognized designation as a pro-solar region. And just again, a note I want to say, same as last time, that we are very excited to have many people here beyond just NVCOG. We have some people from different parts of Connecticut, so we welcome all of you, and we hope you'll all find this interesting and informative. So at this point, I had planned to introduce Danny, our SolSmart rep, but he is sort of frantically emailing me right now saying that none of his passcodes are working and he can't quite get in. So I think maybe I can just give a very quick spiel about SolSmart. SolSmart is a nationally recognized designation program. It recognizes cities, counties, and regional organizations that foster the development of mature local solar markets. SolSmart is a really, really wonderful program. It is somewhat similar to Sustainable CT, if you're familiar with that, in that you can perform certain actions and receive credit to get your designation. So there are a few communities as well as one region in the state of Connecticut that have SolSmart designations, and we're all, we hope that you will consider for your own community to get a SolSmart designation as well. So I don't know, we just had a caller come in. Is there any chance that that's Danny? Maybe not. Okay. Well, with that, I guess I'll go right ahead and introduce our speaker for today. So our speaker today is Bill Brooks. Bill is the principal of Brooks Engineering, which has trained over 15,000 contractors and code officials over the past 25 years, including trainings across the US and territories. His publications include the expedited permit process for PV systems, the field inspection guidelines for PV systems, and understanding the CAL FIRE solar PV installation guidelines. His areas of expertise range from PV fire safety to solar-related litigation, to designing and engineering, to field inspections. We are so pleased to have this expert with us today. And with that, I will turn it over to Bill.
Great, let's see. Okay, let's get things going here. Thanks so much, and great to be here. I'm coming to you from the West Coast, but we're going to be talking about permitting, and it's something that's been near and dear to my heart for a long time, and hopefully provide you with some good resources that you can use, and we're certainly here to help you use those resources. I'm trying to get to my top of my screen. Let's see, I think I'm gonna have to do it through. Nope. Okay, there we go. So thank you for the opportunity to be here. And I am been in this field for 34 years. Actually grew up in upstate New York so not too far from where you folks are. And spent a lot of time in Connecticut because my brother went to the Coast Guard Academy at New London, and lived in that area for quite a while after, throughout his career. Taught at the academy for many years, was captain of the buoy tender out of New London, lived in Mystic. I guess the Newport to Bermuda race is going on probably this week or last week, whatever. He's up there. So Connecticut is near and dear to my heart, and been involved there quite a bit. And so it's great to have this opportunity to meet with you folks. And we're going to be going briefly through the guidelines that are on the website. I put in the chat the web page on the SolSmart resources, and we're going to introduce you to these things. We're not going to go through them in great detail, kind of hit the high spots. And as you get into these things, these are resources to help you do your job and to provide some level of consistency that would hopefully be helpful as these projects become more and more common. So a little bit more about SolSmart, but it's all over the United States. And this is actually an old map, but it just gives you an idea of the communities that are all over. We have over 460 communities at this point. And jumping right into the materials, which will be provided. There'll be PDFs of these presentations at the end. So don't worry about taking too many notes. But this is to provide a format for local jurisdictions and contractors for simple permitting of PV system installations. And we've added recently energy storage, as many PV systems are now including energy storage these days. These are intended to cover the vast majority of small residential PV and energy storage systems, and to provide simple criteria for requirements of these systems. I'm on the National Electrical Code making panel 4. I've been on that code panel for about 13 years. And my job, or my one of my callings, and all the things that were listed there, is to try to make this stuff, demystify it, make it a little simpler for folks to get it right. I don't feel like having a gauntlet out there to make things difficult is the right way to do it. If we give them good tools to do it right, I'm on almost every standards committee that covers the product standards for this area. And so try to make the product standards clear, and we have safe products. So we have got a great safety track record, things like that. So these are the national simplified permitting guidelines for energy storage and PV. And there's essentially a list, an eligibility list of, one of the things I like to call it is a box. So we create this box of, if you can fit your system inside this box that we've created, then you are more like the vast majority of systems that are out there. And by doing that, you make it simpler for everybody. And if you meet those criteria, it makes it easier for enforcement. It makes it easier for the contractor. It makes it, the customer is going to have a better experience. And doesn't mean that that's the only way to do it. Obviously, every community's got a permitting process whereby you can take any project through, construction project through. However, when we have this defined process, it makes it more straightforward, and there's an opportunity to provide some simplification in the overall process. So there's a simple structural review, an electrical review. And just to give you an idea, we're not creating any new requirements. These are all explicitly or implicitly in the codes that we work with. Of course, the National Electrical Code, the International Residential Code, which are the two primary codes that we'll be working with. the IBC and IFC generally don't come into the play in residential projects because the IRC already covers those. And then of course, ASCE 7, which is the structural codes, are embedded in the residential code. So let's see, there's somebody there waiting to be admitted, so I'm admitting them. Purposes of simplified permitting. And we're not trying to supplant engineering, but we are trying to eliminate the need for detailed engineering. I know that there are a lot of communities in the Northeast that want to see engineering on all the structural calcs and things like that. That's really not necessary. And we have a long structural commentary to go along with our structural work. It's over 60 pages long, which explains in detail why the structural calcs and the structural criteria that we have in our process meet the requirements of the code, and that you're not going to have any issues related to structural issues or failures. But there are a lot of similarities between these simplified systems, and we're looking for clearly compliant electrical with the electrical codes and building codes. And the fire codes, by the way, have been embedded into the residential code. So that wasn't always true, but it is now. And so, excuse me. So we have a variety of steps in this process. The first step is gathering the information, and that is every community typically has some type of a permit application that's required. It has information on the project scope and location, who's installing it, things like that. And then there's going to be some basic site plan that shows location of the major components, where the solar is on the roof, where the energy storage is, if it's installed, and where the connections are, things like that. And then there's a series of worksheets that the contractor can put together. And again, it's a process that's really designed to help the contractor give the local jurisdiction the information they need to have. And by having this fairly detailed process, which is generally more than a lot of contractors provide to a local jurisdiction, it does help mitigate the process of going back and forth, which tends to be probably the most time consuming part of the permitting process, is contractors submitting incomplete materials and then having to gather those materials and the timing that it takes to go back and forth. One of the benefits of COVID, if we could say that there were any, is that many communities across the United States have implemented far more online processes than they had before. And so by having a means of moving documents back and forth electronically and having portals and things like that where those can be received, it can be a lot easier on the permitting staff as well as on the contractors in their submitting of materials. And then we want to submit any installation manuals, specification sheets, things like that that are relevant to the project. And again, this is done a lot better electronically. Some of these manuals, by the way, can be as many as 200 or 300 pages long, when the actual installation part of it is only maybe 3 or 4 pages long. And so, you know, for communities that say, well, we have to have 3 copies of everything, those manuals can become a lot of paper. And so highlighting just the installation portions of them can be a big help. Excuse me. Before I jump into this, let's see if I can just bring up real quickly here's the web page for the solsmart.org/permitting website. And so what you'll see here is there's a basic description, just like what we were talking about, and then it goes through and goes through the electrical, gathering the information, and reviewing the electrical code requirements. And so you get the point. Energy storage, electrical code requirements, the residential code requirements for installation, and the like. So I just wanted to make you aware that information is there and readily available to you. All right, let's go back to where we were. So here's this gathering the information. So again, I'm not going to read this through to you. We don't have the time anyway, but I just want to make you familiar with the format. And this is essentially like a checklist and providing the information. And again, it's a format for the contractor. This is not something that the local jurisdiction is filling out for the contractor. This is the local jurisdiction says, here's a resource whereby you can submit a set of documents to us. And if you use this format, this is something that we've seen before. Now, of course, many of you haven't seen it before today, but the idea is that by seeing this and becoming familiar with it, now we have something that, oh, okay, now I'm starting to see these things. They're looking more familiar to me. I'm seeing how they work. And now I can see when things are missing and when things are all in place. We get into the electrical code requirement side of things, and we get into the components about the grounding equipment and all the boring stuff that you have to do in order to do something according to the National Electrical Code. So this goes through that process, and the wire sizing, the voltage ratings, all the things that are relevant to these types of systems. We have rapid shutdown, things like that. And then we go into step 3, which is the electrical code requirements for energy storage systems, which is actually pretty simple when we get right down to it. That's where we're getting into, there's a listing process, UL listing process, UL 9540, which basically sets up the requirements for safe installations of energy storage systems in buildings. And it was specifically set up initially for residential and for other commercial buildings. And then we get into the residential code requirements. And so in the residential code, and I know I haven't looked up what Connecticut residential code, if somebody can maybe put in the chat what version of the residential code you're on. There are quite a few different versions of that code, but the 2021 code is the most recent, of course. There it is. So the 2021 has a lot more information in it than previous versions of the code, the 2018 code, and has some basic information like the requirement for UL 9540, and it states that you can't have energy storage systems in habitable spaces. About what it says. There's not much more in there for the residential code. The 2021 code is a lot more detailed in getting into the finer points. It's not, the 2021 code's not at all in conflict with the 2018 code and previous codes, 2015 code, but it is a lot more detailed. And so these guidelines are based upon the 2021 code. Again, the point here is not that you're enforcing the latest code or anything like that. The point is that the detail that's in here, it's a box. And if the system, if the installation meets the requirements of the box, then it achieves a simplified process. It's easier for everybody involved, and your community may have a simpler process as part of this SolSmart designation process. You have a pathway that's simpler for the contractor and the homeowner to get their projects approved. And we're putting quite a few restrictions on it, by the way. And so those restrictions happen to be found in the 2021 code, regardless of what version of the code we're working on. So that's just to put it in perspective. Again, it doesn't mean that if you're on previous versions of the code, you can't use those codes and do things differently. It just wouldn't be part of this simplified process. The The interconnection requirements, the electrical interconnection requirements are very important. Of course, there's utility interconnection requirements. That's a whole separate set of requirements. Those are based on, that's unique from utility to utility. But the electrical interconnection requirements are just simply how we make the electrical connection into the service panel of the house and things like that. And so there's a variety of ways of doing that in the National Electrical Code. This goes through those basic requirements. And there's choices on how those systems could be installed. The last step, there's two different steps as part of this one. There's a simplified structural set of requirements. That simplified set of requirements is based on very similar, if not identical, to the solar app. If some of you may have heard of the solar app, that's a process that a lot of communities throughout the country are establishing, which is a totally online process where information is input into an online form, and the process is automatically approved based upon the inputs to the online form. And so this is intended to match up with that online form in a somewhat, I guess, a sheet format or a checklist format. So if you have a community that's interested in moving towards solar app, this can be a decent stepping stone in that direction. It takes time usually to get those things set up for a community. And so definitely what I see is that this process that we've been building for well over a decade, maybe 2 decades, has been the stepping stones that have kind of brought us toward the place where we can move into something like a solar app option. And so this gives you an idea of what the structural requirements are in the solar app. There are communities, I know in the Connecticut region, where they do require structural engineering on every system. And in that particular case, I would recommend moving toward the detailed version of it, because the detailed version of it actually is as good or better than most engineering reviews that would be done for residential construction. So we have a detailed version. There are many steps in this. Again, there's a 60-page commentary. We also have a commentary on the electrical side to back up all this stuff. But the structural portion of it is very well defined, put together by structural engineers and reviewed by structural engineers. And so again, this is not, we're not producing stamped documents or anything like that, but I believe that these things are in the best interest of the community, fully as good as any structural engineer could do for a project. So again, mentioned the box using the standard diagram. So we'll show you some standard diagrams. It's primarily set up for 1 and 2 family dwelling structures, or structures of the same construction. So we do have some structures in our communities that where it may be converted homes for various types of small businesses. And if that construction is the same as 1 and 2 family construction, then the structural calcs, for instance, for the roofing and all would be identical. So we have different options for different types of electronics in our systems. They're called string inverters, DC converters, or microinverters. And so we'll get into those details. So we put some limits on our process to help define what's going on, and this is going to cover Connecticut. We're not going to cover in our basic document, we're not covering anything higher than 60 pounds per square foot or 150 mile/hour wind regime. We do actually have addendums that can go all the way up to 180 miles per hour for Southern Florida. And for Martha's Vineyard, where we can have those kind of wind speeds. And if you look at the map of the United States, that red line would be your 150 mile per hour, above 150 mile per hour, or the dividing line for 150 mile per hour. And then the blue line would be your snow loads that are above 60 pounds per square foot, which would include the Upper Peninsula, Michigan, and Maine, in that area up there. Excuse me. Let me get rid of this on my screen. Now, there are some case study areas for wind loads and snow loads, which are in higher elevations. And so in the Appalachian chain and things like that, Mount Washington, of course, up in Vermont, very well known for its extreme winds and snows. And so that would not be consistent with the rest of the areas around it. And so there are some case study areas that are specific, and certainly those communities are pretty well aware of the special cases that occur in their communities. So again, here's kind of an overview. We have two different processes for the structural side and the detail process. We have member attached, where we're attaching it directly to the rafters or trusses, making connections directly to the structural members. And again, 60 pounds per square foot, 150 mile per hour wind regimes, and no exposure D. So we're not going to be putting these things. So this process is not designed to take into account, for instance, somebody who lives right on Long Island Sound, for instance, which is a body of water large enough to put you into exposure D. Not on a steep hill. Now, you do have some steep hills. So if there's a house that's on top of a hill that's got greater than a 5% grade, that's going to create some extra wind pressure. So we're eliminating some things from the list that would have to be done specifically by a structural engineer. Roof mean height of 40 feet. Now, that's exceptionally high. And I know there's some really nice mansions in Connecticut, and there might be a few of them that have a roof mean height that's greater than 40 feet, but that's an enormous structure. That means that the peak of the roof is probably upwards of 45 feet, could be even close to 50 feet. And so also that the roof structure meets the IRC. So there's an assumption that the structure that we're working with has been installed according to the code for the area. So it's a basic assumption, and that there's been no structural damage to that structure. So again, in order for the calculations to work, which there's thousands of calculations that have gone into this stuff, we have to make sure that the structure not only was built for that community, and that it hasn't been modified in such a way that either by water damage or by a structural alteration that was not approved. We can have structural alterations that are approved, and that would not be a violation of this at all.
Gil, quick question.
Go ahead.
Can I ask a quick, Gil Gravel?
Sure.
IRC, which I think there's only 3 people on this list that would know what IRC means.
Right.
So, if you want to state that it's an international residential code, that helps a lot of these folks. And are you assuming, and that's a capital A there, and you know how we spell assume, that these houses that you're assuming that meets the IRC, are they newer homes within the last 10, 15 years, or are they 100 years old, and you're assuming that the old 2x4s up there will take all your extra weight and everything else? There are a lot of assumptions in this this situation. All right, I'm just saying.
Right. Well, thanks for that. Yeah, and I kind of breezed over the IRC, calling it the residential code earlier, but that is the basic code for 1 and 2 family dwellings. And obviously the housing stock in Connecticut has a long history, some of which is hundreds of years old and some of which is brand new. So certainly anything built in the last 30 to 40 years was covered by some type of a building code, typically, especially in the larger communities, but that's not always true. And so there is information in the commentary about working with older types of construction. The good thing about older types of construction is the wood quality and the dimensions of the wood tends to be quite a bit better. And so to the extent that those things can be used, that's great. But in many cases, for an older house, there may need to be some type of a additional structural review done by a design professional. So the idea here with these assumptions, I think, and I'm glad you brought this up, we're not assuming that every house meets these requirements. What we're saying is that a house that meets these requirements, you can use this process and it's 100% in compliance with the residential code structural requirements. So that's the better way to state it. And so I apologize if that was confusing. So your newer communities, your newer subdivisions are going to meet these requirements straight up. And older homes, which are very common and very familiar with in the Northeast, many of those will, because of the strength of the construction, and some of them may not, or they would need to have some type of a structural review done on them. One of the good things about time is that time kind of shows the defects in everything, and also shows the good things about things in construction. So we have older homes. You can see older homes where there's sagging, roof members and things like that, and you can say, okay, well, you can see that roof was probably wasn't meeting any type of a code requirement. It may be holding the shingles up, and that's about it. So that could be obvious. There's also homes. I lived in North Carolina for 17 years, and we had homes on the Outer Banks of North Carolina that had been through 10 Category 5 hurricanes, and they're still there. I'm not at all concerned about the structural strength of that building whatsoever. The fact that it's still there and it's been through these massive storms is a testimony to its strength. And so, that's just kind of an anecdotal thing, but that's, thanks for the question. And again, we're saying that if it meets these standards, and you and your communities have a pretty good idea of the subdivisions that are newer versus those that aren't.
Yeah, and Bill, as long as we're paused here for a moment, Gil also put another question in the chat earlier, which was, what type of license do you need to install PV systems?
Well, that varies state by state. So, and even can vary community by community. So in the Northeast, I believe that most of the communities require some type of an electrical license, but it's maybe somebody from locally there can give us a more accurate. Excuse me. I know in Massachusetts, for instance, which is very strict, you have to be an electrical contractor, and so there's different requirements. There could be a general contractor requirement where electrical work has to be subbed to electrical contractors and things like that. So I'm not going to go into these next several slides in much detail, just because we don't have a lot of time, and I want to get to the inspection portion as well. But this is going through the member attached requirements, which how far the array is off the roof, where the anchors are installed, the gap under the modules, the gap between the modules, the mounting rails, the spacing of the roof attachments, the anchor fasteners and things like that, all covered in this document. Sorry, my throat is giving me a little problems right now. Sorry about that. So the structural takeaway here is that buildings that were built in compliance with the building codes can support PV. So that's so if we show that were a house built in the last 30 to 40 years and they were built according to the codes, we're in good shape. If it's older than that and is in compliance with the current building codes, we can also show that. A single layer of roofing is a basic assumption. So a lot of homes might have 2 layers of shingles. So this is assuming a single layer of shingles if we have comp shingles on the roof. The mounting is within 2 to 10 inches off the roof deck. Distributed weight of the system is going to be less than 4 pounds per square foot. These are all the assumptions that went into the process. Most systems are around 2 to 2.5 pounds per square foot. So there are very few, if any, PV arrays that are over 3 pounds per square foot. And then typical rafter supports that are 48 inches apart or closer meet structural code requirements and represent most of the housing stock. So we're going to have most of our housing stock has rafters 2 foot on center, 16-inch on center, things like that. And that is going to work out in the vast majority of cases. Okay, there are options for low wind load and low snow load areas. That would not include Connecticut. And so just to let you know that those things are out there, and there are additional requirements that are eased up in those very specific low snow load and wind load areas. The second type of attachment method is a sheathing attach method. We don't go quite as high on the wind speed side of things. And again, it covers Connecticut and certainly the snow load parts as well. The roof mean height's a little bit less, 30 feet. Again, certainly all your construction for subdivision construction and stuff like that is going to fit within that 30 feet. But there may be a few homes that actually exceed 30 feet, which means, again, the peak of the roof is going to be somewhere around 35 feet. And then there's some more requirements in here for the sheathing attached process. And this is just looking at areas of the country where sheathing attached can be used, which is the vast majority of the country. And with the attachments, well, one of the things it gets into is where the attachments happen on the structural sheeting, and that gets into details that are covered in the bands of strength of the sheeting. If you're at the edge of the roof, then you want to be in the bands of strength, and if you're not at the edge of the roof, you don't have to be in the bands of strength. And so there's a lot of detail about that, and these are, again, part of that detailed structural process, especially for communities that are generally looking for engineering for structural attachments. This is a very, very detailed approach, which includes tributary areas of the attachments and all the rest. And then just want to point out finally here the general statement that if any structural item can't be checked off, then the building official may require the installer to provide structural calculations or details stamped and signed by a design professional. So that can be for a specific item that's not checked and that they do a review on, or it could be for the whole thing. So the second step is the electrical system requirements, goes into the details of what is necessary in the electrical code. We saw this earlier. And then the interconnection requirements. And so we're going to jump through a few examples, and then we're going to move on to the inspection process. So here's a very simple electrical diagram for a PV system that's connected directly into the main service panel. This is by far the vast majority of systems that have been installed throughout the United States that don't have energy storage look something like this. And so there's items up here, tags that call out all the materials, all the equipment that is used in this process to make this connection. And then the wiring types and conduit sizes and all that kind of stuff is covered down here. And so this is essentially a fill in the blank single line diagram to show what equipment is being installed, and then it meets the basic requirements of the electrical code. So moving forward, let's just show you an example of a system that's got 27 panels, a single inverter, and then this specific mounting system. And so here we have this happens to be a sheathing attached system, and the notes cover the basics of that equipment. It shows where the attachments are, these little black circles of the attachments, and the conduit coming down off the roof, and the details and the call out of the equipment for the installation. Shows where it is, shows that it has setback requirements for fire setbacks, things like that. And here's the filled in electrical diagram for that particular installation. And then this is the notes pages that covers the modules, the inverter, the signage that's required and stuff like that. Microinverter systems are very common. And so there are microinverters and AC module systems where the microinverter is built into the module. And here's an example of a fairly similar size system with 26 modules and microinverters. There's one inverter on every module here. And here we have a hip roof arrangement with most of the modules on the south face and some of them on the west face here. And then we have this 4-foot on center attachment to the rafters here. And it's in a staggered fashion. So that's for compliance with the snow loads and wind loads. The attachments being staggered like this provide a fully distributed load on the roof, where essentially every rafter is sharing the weight of the array as it's covered across the roof. Here's the electrical diagram for that. And so you can see how each module is attached to microinverter, and then there's a cabling system that brings it all together. And this diagram covers that and the tags that go along with it, along with the notes pages that go along with that. So as I mentioned, we've added energy storage to the process. We don't have a lot of time to cover it, but when we get into energy storage systems, there's a variety of ways that these things are connected. So we have several different styles of energy storage systems showing backup, since a lot of these things are being used for backup power during ice storms and various storm events that might occur. Then this shows those details with the battery coming into it. There's different style systems like the Tesla Powerwall, which is a fairly common system that you may have already seen out in the field, or at least heard about it. And so how those systems are installed gets kind of complicated. And so that's why having this standardized process can be helpful to show different ways these things are installed, different formats, and how they go together. And provide some basic coverage of those different methods. Microinverter systems with energy storage, Enphase Energy, which is the most popular microinverter company, has their process as well. So with that, I want to leave the last 15 minutes or so to talk about the
and Bill, I'm just gonna pause you here for a second. We do have one question in the chat.
Go ahead.
David asks, are there standards for ground mounted installations?
These guidelines structural guidelines are not intended to cover ground mounted systems. However, most ground mounted products that are out there on the market today offer engineering services as part of their packages. And so they'll have the ability to provide engineering in whatever location, including Connecticut, where an installation would go in. So it would tell how deep and how large the footings would have to be, things like that, for their installation for their structural pieces. So there are standard engineered products on the market, probably a dozen different manufacturers of these things, and at least half a dozen of them provide engineering services for their, throughout the United States. And somebody could also build their own system and have it engineered by a local engineer. So those are going to all have engineering calcs that go along with them, and that's standard procedure.
Great,
Anything
thank
else?
you. No, you're good to go.
Alrighty, well, let's jump into this. We don't have a lot of time, and I know everyone's time is very precious, and so we're just trying to give you a high-level view of this. And this is a inspection checklist. It's a little one-page checklist where a field inspector can go through and check off the major items that are important to the installation of these systems. And so when we start up with, do an inspection, I've done hundreds and hundreds of inspections over the years for jurisdictions and for various projects. But having this kind of format is really helpful in making sure we're ticking all the boxes. Normally when we're doing an inspection, where all our disconnects are going to be in the off position, everything's going to be turned off. Obviously in this picture right here, the system has been approved and is up and running. And one of the things that I put together dozens of checklists over the years, and the last probably 5 or 6 years, maybe more, in working on the checklist. One of the things that's basic in the electrical code is electrical work should be done in a neat and workmanlike manner. And so what we mean by that is that it is a somewhat subjective item, but the idea is that things are clean and neat, done not only professionally, but look professional. And that way we can see when things are out of place and something's wrong. And so we want to see installations that are done neatly without wires hanging down all over the place. Here's an older home where looks like an old split level, doesn't it? You probably got a few of those. I tell contractors is that when I look up underneath the PV array, I want it to appear as if it's wireless technology. What do I mean by that? I mean that the wires are neat and tucked up, because if they're hanging down, snow and ice will have a tendency to grab a hold of them, could even tear them loose. And so, and they look unsightly. So we're using external cable systems, so it takes a lot of time and effort to make those things look neat and clean. But that's going to be helpful in the long term. And there's all kinds of good, bad, and ugly looks to wiring systems. So we want it to look something like that, nice and clean and neat. And how in the world do they get the electricity out of this thing? Well, you're going to find a conduit somewhere, but yeah, there's all kinds of craziness that happens. Here's a good example of some craziness. Structurally, it's got all kinds of issues, but aesthetically, it's far worse. And so we don't want that in our communities. And that's why we talk about the arrays being no more than 10 inches off the roof deck. So they have to be a little bit separated off the roof deck for cooling purposes and moisture and all, but we don't want to see them way up in the air. They look unsightly, and structurally, they're not going to do very well. Any kind of roof attachments, penetrations that have to be flashed. We want to see this flashing done correctly. Here we see a flashing that wasn't installed correctly. We have special types of roofing materials that have special flashings. And so make sure that those things have the correct flashings. We have, here's some examples of exposed wiring where the wires are just hanging out all over the place. This is visible from the ground. It's certainly not properly supported or secured. And so by installing the conductors properly and out of the way, you can't see them from the ground, and they're actually easier to work on. should there be a need to work on them. And you'll notice here, this installation, this subdivision had numerous houses with solar on the roof because this installation looked good. Their neighbors said, "Oh, that doesn't look so bad. I think, oh, what's your electric bill? Maybe I'll do that too." So one of the benefits of having aesthetically pleasing systems that meet the requirements is that other people might want to do the same thing, and it enhances the community rather than detracts from the community. So yeah, unsupported, unsecured flex on roof, things like that. We don't want to see that kind of stuff. The residential code, which we talked about before, has specifics on setbacks for firefighters and things like that. This happened to be a house that unfortunately had a fire, had solar on it. Firefighters had plenty of room to do their work, and so everybody was kept safe, and the house was able to be protected by the firefighters. There's actually fire classifications of PV equipment. And so the documents talk about the compliance with those fire requirements. That may not be as major an issue in Connecticut as it is here in California. I live in an area where we had a major wildfire come through my community, and several of my neighbors lost their homes. And so we were fortunate in not losing ours, but it can and do happen. And we've even had fires recently in California that took out a lot of homes. So those are unfortunate. And so we make sure that these things do have the right fire ratings, grounding equipment installed, the proper labeling of the equipment. That's what an inspector is looking for. Proper conductors being used. Most systems, they're not going to have fusing, but if there is fusing, that the proper fuses are used, proper disconnects. So, the plans are, if they call out different disconnects, that they're according to the approved plans. The connections in the panel meet the requirements. Signage requirements are met. So in the standard plans, the notes page has the requirements for the signage that the code requires. Here's an example. I know this never happens in Connecticut, but this is kind of a humorous example where the customer was having their house repainted and stuccoed, and so they I guess they had the forethought to mask off the meters on the devices and stuff like that, but they sprayed right over all the signs that were on there. That was a bit unfortunate, but it looks pretty, and they thought it looked pretty, but all the signs got obscured, unfortunately, in that case. Grounding electrodes. A lot of the older homes may have water pipe grounds. That's very common. Some of those water pipe grounds could be good, but most communities where electrical work is being done might require augmentation with driven ground rods and things like that. And so I'm sure there's folks on this call that are familiar with those types of requirements. But that's when somebody's pulling a permit that's got electrical work in it, that's often a basic requirement. So access to equipment and maintenance. There's a tendency for people, they don't like the looks of their service equipment or their meters and stuff like that. So they do plantings right in front of the equipment. And that can be a real problem for access to electrical equipment or not follow the rules at all. Here's an example of an old school flooded battery, which we don't have anymore in these types of systems. But the only way you could work on the electrical for this particular system would be to stand in the battery box, and that just seems like a bad thing. And of course, is a violation of the code. The rapid shutdown is something that's been added to the electrical code in the last several code cycles, specifically for improving the safety for firefighters as they're working on this equipment. And so all your systems are going to have to show compliance with the rapid shutdown requirements. And that's why we have a lot of microinverter systems that are inherently compliant. And this is an example of a microinverter system here. And then SolarEdge, which uses DC optimizers, there's DC switch products that are out there. Tesla has their own listed process, and so there's lots of different options for compliance for the safety of firefighters in the electrical code. And with that, look, I landed the plane within the hour. Just wanted to cover those things briefly and quickly. Also let you know that I am here as a resource, and I'm more than happy. I know that there are several folks on this call that you may not be the ones that are actually doing the plan reviews or the inspections, but you certainly know the folks in your community that are doing those on a day in and day out basis. And those folks are going to come across questions and concerns, and certainly here to help answer questions in this area. I've got several decades of experience in this, been doing this for 34 years now in my entire career. And if I don't know the answer, then, well, that should be a problem, but I'm sure I can find it if I don't happen to know the answer. And we're here again as a resource to help you do your job effectively in your communities. And we want to see more solar done. And because of that, we want to make sure that things are done properly. So with that, I'll turn it back over to Christine. And
yeah, thank you so much. Very informative. I know that was a lot of information, maybe a little overwhelming, but I appreciate Bill being mindful of everyone's time. Please do recall, we will have this recorded and available to you, as well as the slides, which we'll send in an email afterwards. So with that, I wanted to open it up to see if there are any questions people would like to ask. And I'd also like to let you all know that Danny Falk from SolSmart is online with us here. So he can also, yeah, he can answer any questions that you may have about the SolSmart program as well. So if anyone would either want to put a question in the chat, or they can just unmute and ask if you have a question.
And if we run into some dead space here, Danny, I know that you didn't get an opportunity to share your presentation earlier, and I'm sure they'll make that available. But if you'd like to say a few words, like I said, we're here to help people out any way they need it related to this stuff. And so, you know, it really. Again, this is a 1 hour presentation covering things that normally we take several hours to cover. And so there was no attempt to try to dive deep and get into all the nitty gritty, which probably would have put most people to sleep anyway. But there's definitely folks in your communities that care deeply about all these issues that we've covered today. And we want to make sure that we're not going to gloss over them. That's not the attempt here. That's not the intent. And we want to make sure that everybody understands that things are well covered, and answer their questions as they come up.
Yeah, Danny, did you just want to unmute and add anything?
Did we lose him?
There we go. Sorry. Sorry about that, everybody. I was double muted and didn't realize that immediately. Quite a day for technical snafus on this end, unfortunately. But happy that everybody was able to attend this great event, and that there's a good amount of interest in the permitting training. And thanks to Christine for putting this on as well, and Bill for the great presentation. And I'm happy to, as Bill and Christine have mentioned, happy to give a little bit of info on SolSmart. I won't give a full presentation, but I'll just mention that if anyone from any communities is interested in receiving technical assistance on what we call the soft costs of solar, which include permitting inspection, planning and zoning, community engagement, the whole 9 yards. We do provide that technical assistance at no cost to interested communities in helping them expand their solar energy within their community. So I'll just mention that very abbreviated version of what I was going to mention, and thank everyone for coming, and open it back up to questions if anyone has any.
All right, thank you so much. Looks like we don't have any questions. So certainly feel free to visit our Solar Hub. We have the link in the chat there, and reach out to myself or Bill or Danny if you have any further questions. Thank you so much, and everyone have a sunshiny day. Take care.
Have a wonderful day, folks. Thanks for coming.
Thanks, everybody.